Hello students, welcome back to the chapter Light, Reflection and Refraction. In this part, we will discuss previous year questions based on reflection of light and spherical mirrors. Let us go to the first question. Mirror X is used in a solar furnace to concentrate sunlight, while mirror Y is used on the side of a vehicle to view the traffic behind the driver. Which of the following statements correctly describe the images formed by these two mirrors? So first of all, we need to identify what type of mirrors they are. So in the first statement, it is given that mirror X is used in a solar furnace to concentrate sunlight. So it is possible only with the concave mirror. Therefore, X is a concave mirror. On the other side, Y is used on the side of a vehicle to view the traffic behind the driver. And we know that the type of mirror that is used in the vehicles is the convex mirror to see the traffic behind the driver. Therefore, the mirror Y is a convex mirror. Now, we need to identify which of the given statements are correct. The first statement says a mirror X forms a real diminished image at its focus. So, mirror X is a concave mirror, and when the object is at infinity, the image will be formed at the principal focus and it is diminished real image. So, therefore, the first statement is correct. And mirror Y forms virtual diminished direct image. So, mirror Y is a convex mirror. We know that the convex mirror forms a virtual diminished and erect image for any position of the object. Therefore, the second statement is also correct one. And mirror X forms a virtual diminished and erect image. So, the concave mirror, so it forms a virtual image, but it is magnified one, not the diminished one. Therefore, third statement is wrong. And fourth one, mirror Y forms a real diminished image at its focus. A convex mirror, it will not form a real image. Therefore, the fourth statement, it is wrong. Therefore, the statements 1 and 2 are correct and 3 and 4 are wrong. And from the given choices, the choice A is correct. Next question, at what distance from a concave mirror should an object be placed so that the image formed on a screen is of the same size as the object? So, the given options are A, beyond twice the focal length, B, at the principal focus, C, at twice the focal length, D, between the optical center and the principal focus. We know that when the object is placed at infinity in front of a concave mirror, the image of the object is formed at the principal focus and it is real, diminished and inverted one. And as the object is moving towards the concave mirror, the size of the object increases and the image, it moves away from the concave mirror. And as the object reaches the center of curvature of the concave mirror, the image also reaches the same point, that is the center of curvature of the concave mirror. And here the size of the image that is formed is exactly equal to the size of the object. Therefore, when the object is placed at the center of curvature, the image formed will have the same size as the object. To understand the formation of the image by a concave mirror, we draw the ray diagram for the given situation. So, here an object is placed at the center of curvature of a concave mirror. We take two rays, one ray which is going parallel to the principal axis and the second ray which is going through the principal focus of the concave mirror. And the first ray which is going parallel to the principal axis, after reflection it passes through the principal focus, and the second ray which is passing through the principal focus, after reflection it goes parallel to the principal axis. This is the object point and the image point is this one. Therefore, the image that is formed is exactly at the center of curvature. The size of the image is same as that of the object. Therefore, when the object is placed the center of curvature, the distance of the object from the center of curvature will be twice the focal length. Therefore, from the given options, that is C, at twice the focal length. Next question, list any four properties of the image produced by a plane mirror, or define the following terms related to a concave mirror. 1 pole, center of curvature, 3 radius of curvature for principal axis. And for this type of questions, I have made short video. List any four properties of the image formed by a plane mirror. So, I have made a simple short video which gives the formation of the image by a plane mirror. Also, it mentions the properties, but anyway, I mentioned the four properties here. The image formed by a plane mirror, it is a virtual image. The image formed is an erect one, and the distance of the image is equal to the distance of the object, and size of the image is equal to size of the object, or the image formed is laterally inverted one, that is the left appears as right and the right appears as the left. And for the second question also I have made a simple short video. which defines all the terms related to spherical mirrors, and you can go through the short video. Anyhow, I mentioned the answers here. Pole of a concave mirror. It is the geometric center of the reflecting surface of a spherical mirror, whether it is a concave mirror or a convex mirror. And center of curvature. Center of a sphere for which the reflecting surface of a spherical mirror forms a part. And third one, radius of curvature. The radius of the sphere of which the reflecting surface of a spherical mirror. So wherever you see spherical mirror, you can just put the word concave mirror. Okay. So if it is asked for concave mirror, then you need to write concave or convex. And fourth one, principal axis. It is the straight line passing through the pole and the center of curvature of a spherical mirror, that is the concave mirror. The next question. Draw ray diagrams to show the position, nature, and the relative size of the image formed by a convex mirror when an object is placed, number 1, at infinity, and number 2, at a finite distance between infinity and the pole of the mirror. So for that, we first draw the schematic diagram of the convex mirror, and we note down the position of the pole and the center of curvature, and we draw a line which indicates the principal axis of the convex mirror. We know that when the object is placed at infinity, the rays coming from the object, they are almost parallel, and if those rays are parallel to the principal axis and incident on the reflecting surface of the convex mirror, after reflection they diverge in different directions. And if you extend these rays in the backward direction, they appear coming from a point on the principal axis behind the mirror. And this point is the principal focus of the convex mirror. Therefore, for the object which is at infinity, the image will be formed behind the mirror at the principal focus of the convex mirror. The image is virtual and it is erect and highly diminished. And for the second case, that is when the object is at a finite distance between the pole and the infinity. So we choose an object which is just in front of the convex mirror. We are choosing such rays that are incident on the reflecting surface of the convex mirror. After reflection, they appear to coming from the principal focus and the center of curvature of the convex mirror. So after reflection, if you extend these rays in the backward direction, one ray that is parallel to the principal axis incident on the reflecting surface of the convex mirror. After reflection, it appears to come from the principal focus of the convex mirror. And the second ray, which is incident normally on the surface of the convex mirror, after reflection, it appears to come from the center of curvature of the convex mirror. And here, the intersection of these two lines, it gives the image point of the object. Therefore, the image is formed in between the pole and the principal focus of the convex mirror. And if you observe here, the image is found behind the mirror. Therefore, it must be a virtual image and it is diminished in size and it is erect one. The next question, the magnification produced by a spherical mirror is +3. So using this, answer A, what mirror is it? B, where is the object placed? C, give two properties of the image. So here the magnification given, that is m is equal to +3. So if the magnification is positive, this indicates the image formed is a virtual image. And here it is +3, that means magnification is greater than 1. So if the magnification is greater than 1, so it indicates the image formed is a magnified image. And this happens only in the case of a concave mirror. Therefore, for the first question, what mirror is it? The answer is concave mirror. For the second question, where is the object placed? A virtual and magnified image is found when the object is placed in between the principal focus and the pole of the convex mirror. Therefore, the object must be placed in between F and P. And the next question is give two properties of the image. To understand the properties, we just draw the ray diagram for the formation of the image. We take two rays that are coming from the object. So one is going parallel to the principal axis, and second ray, we are choosing such a ray. After reflection, it passes through the center of curvature of the concave mirror. And if you observe here, the reflected rays, they are not parallel to each other. They are actually diverging. So therefore, the image will be formed behind the mirror. That means if you extend these two rays, they will meet at a point behind the mirror. And the image formed is a virtual erect one. And the properties of the image, they are virtual, erect and magnified. Next question, define the principal axis of a concave mirror. So whether it is a concave mirror or a convex mirror, the principal axis is defined as a straight line that is passing through the pole and the center of curvature of the spherical mirror. The second one, a ray parallel to the principal axis reflects and then passes through the point on the axis that is at a distance of 10 centimeter from the pole. Find the radius of curvature. So here it is given that a ray which is parallel to the principal axis, after reflection, it is passing through the point that is at a distance of 10 centimeter from the pole. Therefore, here the given spherical mirror is a concave mirror because a ray which is parallel to the principal axis, after reflection it is passing through the point. That point must be the principal focus of the concave mirror. Therefore, the given distance, that is the 10 centimeter, is the principal focus of the concave mirror. Therefore, it must be the focal length of the concave mirror, that is f is equal to 10 centimeter. Since we know the focal length of the given concave mirror, we can calculate the radius of curvature of the concave mirror, that is radius of curvature, that is equal to twice the focal length. Therefore, 2 into 10, that is 20 centimeter. Now for the third part of the question. So for a convex mirror, the object is at 10 centimeter and the focal length is 15 centimeter. Find the image position. That means we need to find out the image distance. The object is at 10 centimeter, that is the object distance u is equal to 10 centimeter, and the focal length is f is equal to 15 centimeter, and find the image position, that is image distance v is equal to how much. And here it is a convex mirror. Therefore, in the case of a convex mirror, object distance is negative and the focal length, this is positive. And we write down the mirror formula, that is 1 by f is equal to 1 by u plus 1 by v. That is 1 by 15 is equal to 1 by u, that is 1 by minus 10 plus 1 by v, that is v. Now if we solve for v, that is 1 by v is equal to 1 by 15 plus 1 by 10. The LCM of 15 and 10, that is 30. So 15 2 times, therefore 2, and 10 3 times, that is 3. Therefore 5 by 30, and from this 1 by v is equal to 5 by 30, and if you take the reciprocal, that is v is equal to 30 by 5, that is 6 centimeter. Therefore, the image is formed 6 centimeter in the case of a convex mirror, that is 6 centimeter behind the mirror. And fourth part, that is D, a mirror that gives a virtual, erect and diminished image. Identify the mirror and draw and describe ray construction. The mirror that gives a virtual, erect and diminished. So virtual, erect and diminished, this is possible only in the case of a convex mirror. Okay, therefore the mirror is a convex mirror, and the second thing is we need to draw and describe the ray construction. So already we have seen in the previous question, when the object is placed in between the infinity and the pole of the convex mirror, the image is formed in between the pole and the principal focus, and that image is diminished and it is real and it is erect and virtual. Next question, an object is placed 30 centimeter in front of a concave mirror. Its real and inverted image is formed at 60 centimeter in front of the mirror. Find the focal length of the mirror. So first we note down the given values. So here it is given that the object is placed at a distance of 30 centimeter. Therefore, object distance u is equal to 30 centimeter. Okay, the object distance is always taken a negative. And second one, a real and inverted image is formed at 60 centimeters in front of the mirror. Therefore, v, that is also negative, that is minus 60 centimeter. And here we use the mirror formula, that is 1 by f is equal to 1 by u plus 1 by v. And we substitute the given values, that is 1 by f is equal to 1 by u. Okay, we make the denominator same just by multiplying the first term with the 2, that is 2 by 60, that must be minus. So this is again minus 1 by 60. If you take the LCM, it is 60. We write minus 2 minus 1. Okay, that is equal to minus 3 divided by 60. So here 1 by f is equal to minus 3 by 60. Therefore, f must be minus 60 by 3. Therefore, the answer is minus 20 centimeter. Next question. A ray of light parallel to the principal axis incident on a concave mirror. Draw the correct ray diagram that shows the path of the reflected ray from the mirror. So for this, first of all, we draw the schematic diagram of a concave mirror. That means we show just the pole, the principal focus and the center of curvature along with the concave mirror. Now we take a ray that is traveling parallel to the principal axis of the concave mirror. And after reflection, this ray, it passes through the principal focus of the concave mirror. That is, the reflected ray passes through the principal focus of the concave mirror. Next question. A convex mirror used as a rear view mirror on a scooter has a radius of curvature 2.4 meter. If a car is located 4 meters behind this mirror, determine the position, nature and size of the image formed. So first thing is a convex mirror used as a rear view mirror. It has a radius of curvature. So we denote it by capital R, that is 2.4 meter. So from this we can find out the focal length of the convex mirror, that is F is equal to R by 2, that is 2.4 divided by 2, that is 1.2 meter. And the next step, if a car is located 4 meters behind this mirror, the meaning is, okay, the car is behind the scooter. That means the car is at a distance of 4 meters from the reflecting surface of the convex mirror. The object distance, that is u, is equal to how much? 4 meters. So always we take the object distance as negative, therefore it is minus 4 meters. And what we need to find out? Determine the position. So position means the position of the image, that is V. Nature of the image, that means whether it is a real image or virtual image. Okay, real or virtual. And third one is size. So these are the things we need to find out. So we use the mirror formula. So mirror formula is given by 1 by F is equal to 1 by U plus 1 by V. And from this, okay, we need to find out the value of V by substituting the values of F and U. And what is the value of F? 1.2 meter. So first of all, we need to note down whether it is a positive or negative. For a convex mirror, both radius of curvature and the focal length are positive. 1 by F, that is 1 by 1.2 is equal to 1 by U, that is 1 by minus 4, that must plus 1 by V. And from this, we need to find out what is the value of V, that is 1 by V is equal to 1 by 1.2 plus 1 by 4. 1.2 is in once. So 1.2 it cancels once. Therefore it is 1 plus, and 4 in 1.2 it is 0.3. Therefore it is 0.3. So 1.3 divided by 1.2. So from this we can write down V is equal to, take the reciprocal, that is 1.2 by 1.3. And if you multiply both the denominator and numerator with 10, so you will be getting 12 by 13. And if you simplify, you will be getting something around 0.92. So meters. The value of V is positive. Therefore, okay, the image is formed behind the mirror. And what kind of images are formed behind the mirror? Virtual images. Therefore, the image formed is a virtual image. So that can be understood from the value of V, that is virtual image. And next one, we need to find out the value of magnification, that is M. And if this value is greater than 1, so that indicates the image formed is a magnified image. And if this value is less than 1, then that indicates the image formed is a diminished image. M is given by minus V by U. And we substitute the values of V and U here. That is minus V is how much? 0.92 and U is, so therefore it will be 0.92 divided by 4. So clearly it shows that the denominator is greater than the numerator. So therefore the value will be less than 1. The image formed is a diminished image. The next question. An object 3 cm in height is placed 22 cm in front of a concave mirror whose focal length is 14 cm. At what distance from the mirror should a screen be placed to obtain a sharp image? So determine the nature and size of the image. So here, first of all, we note down the given values and also we understand what we need to find out. First thing is an object 3 cm in height, that is the height of the object is given, h is equal to 3 centimeters, is placed 22 centimeters in front of a concave mirror. That is the object distance u is equal to 22 centimeters. Since it is object distance, it should be negative. And the focal length of the concave mirror, it is 14 centimeter. That is f is equal to 14 centimeter. And the focal length of a concave mirror is taken negative, therefore minus 14 centimeter. So at what distance from the mirror should a screen be placed? That means the image distance we need to find out, that is V. Determine the nature and size of the image. So nature means whether it is a real image or a virtual image. Okay. And size of the image, that is the height of the image formed. Here we start with the mirror formula, that is 1 by f is equal to 1 by u plus 1 by v. And we substitute the given values, that is 1 by f. 1 by f is 1 by minus 14, that is equal to 1 by u, that is 1 by minus 22 plus 1 by v. The next step, 1 by v, that is equal to 1 by 22 minus 1 by 14. So here we take the LCM. 1 by v is equal to, okay, the LCM of 22 and 14 will be 144. 7 minus 11. That is equal to, so minus 4 divided by 144. And if you simplify further, so we can write down v is equal to 144 divided by 4 minus 36 centimeters. Okay, the image formed is on the left side of the mirror. Therefore, it is a real image. Next one, the size of the image. For finding the size of the image, we need to find out the magnification first. Magnification is equal to minus v by u. And minus v is how much? Minus 36 divided by u. That is minus 22. That is 18 by 11. And the magnification is also having another formula, that is height of the image, that is h dash, divided by the height of the object, that is h. So this can be equated to the value that we got in the previous step, that is minus how much? 18 by 11. And from this you substitute the value of h, that is h dash divided by h is 3, that is equal to minus 18 by 11. And from this h dash is equal to 3 into 18, 54, minus 54 divided by 11. That is minus 4.9 centimeters. Therefore, the image formed is a magnified one when compared to the size of the object. Next question. A 6 centimeter tall object is placed 24 centimeter in front of a concave mirror whose focal length is 16 centimeter. At what distance from the mirror must a screen be placed to obtain a sharp focused image? Determine the size and the nature of the image. So first of all, we note down the given values and then we try to understand what we need to find out. So first thing is a 6 centimeter tall object, that is height of the image is given, that is h is equal to 6 centimeter. And next one is, okay, this object is placed 24 centimeter in front of a concave mirror, that is object distance u is equal to 24 centimeter. So object distance is negative, so minus 24. And the focal length of the concave mirror, that is f is equal to 16 centimeter. So focal length of a concave mirror, therefore it must be negative 16 centimeter. So first of all, okay, if the focal length is 16 centimeter, then the radius of curvature will be 32. So 32, that means this object is placed in between the center of curvature and the principal focus of the concave mirror. Therefore, the image formed will be real, inverted and magnified. You need to find out the distance of the image. V is how much? And determine the size, that is height of the image, that is h dash is how much, and nature of the image, that is whether it is a real image or virtual image. First of all, we find out the value of v, that is we use the mirror formula 1 by f is equal to 1 by u plus 1 by v, and you substitute the values of the f and u, and from this get the value of v, that is 1 by v is equal to 1 by 24 minus 1 by 16. The LCM of 24 and 16 will be 48. So 24 cancels 2 times, therefore it is 2, minus 16, it cancels 3 times, that is 3. So this will be minus 1 by 48, that is the value of 1 by V. And if you just take the reciprocal, so V is equal to minus 48 centimeters. The value of V is negative, that is the image is formed in front of the reflecting surface of the concave mirror. Therefore, the image formed is a real image. The next one is, we use the formula for magnification, that is M is equal to minus V by U, and that is equal to minus V, that is minus 48, divided by U, that is minus 24, and that is equal to how much? Minus 2. The size of the image is bigger than that of the object because M value is greater than 1. And we also have the formula for magnification, that is M is equal to H dash by H. We can equate the value that we got in the previous step with the equation, that is H dash by H. Therefore, H dash divided by H, that is 6, is equal to minus 2. So from this, H dash is equal to minus 12 centimeter. So minus 12, so magnification is 2, that means exactly twice. Okay, the size of the image is exactly twice that of the object. The height of the object is 6 centimeter and the height of the image is 12 centimeter. It is negative, that means the image formed is a inverted image, and the nature of the image, that is real and inverted one. Next question, a convex mirror used as a security mirror has a radius of curvature 4 meters. If a person stands 6 meters away from it, find the position and nature of the image formed. So what is given here? The radius of curvature of the mirror is given, that is capital R is equal to 4 meters. And if a person stands 6 meters away from it, that is the object distance, U is equal to minus 6 meters. And from these values, okay, from the radius of curvature, we can find out the focal length, that is F is equal to R by 2, that is equal to 4 by 2, that is 2 meters. For a convex mirror, the focal length is positive, therefore it is plus 2 meters. And we use the mirror formula now, that is the mirror formula 1 by F is equal to 1 by U plus 1 by V. From this we find out the position of the image, that is the value of V. We substitute the given values, that is 1 by F, 1 by 2, that is equal to 1 by U, that is minus 6, plus 1 by V, and from this 1 by V is equal to 1 by 2 plus 1 by 6. And if we simplify this one, 1 by V is equal to 1 by 2 plus 1 by 6. So this can be written as 3 by 6 plus 1 by 6, because it can be written as, here the numerator and denominator is multiplied by 3, therefore it becomes 3 by 6. Now the LCM will be 6, therefore 3 plus 1 in the numerator, that gives 4 by 6. We take the reciprocal here to get the value of V, that is V is equal to 6 by 4.5 meters. Therefore, the image is formed at a distance of 1.5 meters. The image distance is V is equal to plus 1.5 meters. So when you write plus, that means the image is formed behind the mirror. Therefore, it must be a virtual image. To find out whether the image formed is a magnified or the diminished, we find out the value of magnification. The formula for magnification is minus V by U, that is equal to minus V, that is 1.5 divided by U, that is minus 6, that is 1.5 divided by 6. From this ratio, you can see that the denominator is greater than the numerator. Therefore, the value will be less than 1. Therefore, the image formed is diminished 1. So, this indicates that the image formed is a diminished image.